So number 1 and number 2 are exactly alike. So if you can do number 1, you can do number 2. So I'll help you with number 1. If you get to number 2 and you're lost, go back and rewatch number 1. The maglev train, one of the bullet trains tested in Japan, was recorded to travel at an average speed of 550 kilometers per hour. The equation below shows the relationship between d, the distance in kilometers the train travels, and t, the number of hours it travels. What is the distance in kilometers the maglev train will travel in 6.5 hours? So our question is, what is the distance? And then we've got some important information. Go back and highlight or underline or circle some of that. Now it says D is the distance and T is the number of hours. I think T stands for time. That's why it's weird that it's T for hours. So anytime you have a formula, first write the formula exactly like it is. And we try to skip this part, but I'm telling you, the higher up in math you go, the more important writing the formula becomes. And then you're going to put in the numbers you know. You know you're looking for distance, so that stays a letter. 550 never changes because they gave that to you. And it's being multiplied times t, which they gave us as 6.5 hours. Whatever the answer to this is the distance. Now remember, when you multiply decimals, you don't line them up. You pretend like the decimal's not here. And then in your answer, you should have one number behind the decimal because that's how many is in your problem. If you're looking at number 3, a squirrel travels at a rate of 20 kilometers per hour. Which representation does not show the distance a squirrel can travel at this rate? You have several different representations. If it were me, I would make a table and find which one does not match. Or just start looking and see if there's any obvious one you can rule out. Be careful to watch the labels on your graphs and your tables. Number 4 says, which table shows a constant rate of change of $3.25? Again, I would make my own table. I have hours and cost. So if it's 1 hour, or sorry, 1 ham sandwich, it's a ham sandwich, it says. 1 ham sandwich, how much does it have to cost if the constant is $3.25? Right? And then, can I cross off any of these? Not yet. None of the tables have number 2, so I'm not going to do number 2. So, if I have 3 ham sandwiches, how much does it cost? Yeah, it needs to cost $9.75. Can I cross off any of these? Well, this one doesn't match and this one doesn't match. So check 5. And then if you have to, check 7. But if it's the constant, you're just multiplying. Find the table that matches yours. Okay, number 5 says the cost of 11 pounds of fertilizer is $33.77. What is the constant of proportionality that relates to the cost in dollars Y to the number of pounds of fertilizer X. So every time you see that word constant, that is K equals Y divided by X, write the formula, all letters, no numbers, write it down right away, right now, every time you see the word constant. And then we're going to replace Y and X with numbers. So in our problem, it tells us that dollars is Y. It says right here, the cost in dollars Y. So how many dollars do I have? Yep, $33.77. To the number of pounds of fertilizer X. So pounds of fertilizer is X. How many pounds of fertilizer do we have? The answer to this is your constant. If you wrote that K equals Y divided by X down, you are golden. So multiply or divide carefully. Don't lose your decimal. So Michael's car can travel at 25 miles on 1 gallon of gas. The cost of gas is $3.75 per gallon. Which equation would calculate the total cost of gas Y based on the number of miles traveled X? This is no joke. This is some real work here. All right, 25 miles on 1 gallon, and it's $3.75 per gallon. So how much does it cost per mile? Right? That's what we want to know. I know it says which equation would calculate the total cost, but we need to know how much, because we're using gas and miles. Let me see if there's a better way to explain this. Hang on, let me think about it. No, that's just about as good as I can get. Okay, how much does it cost per mile? Well, our cost is $3.75 per gallon, and we have 25 miles. So how much does it cost to go 1 mile? Well, how much does it cost? We can go 25 miles for $3.75. This is your constant. And remember our triangle. Oops, now I even got our triangle wrong. Oh my goodness. Our triangle with Y on top says if you're looking for Y equals and you cover up the Y equals KX. So this number goes here. So whatever number you get needs to be right here in your equation. Do your division and find it in your answer. Which equation could be used to represent the data in the table? You're looking for constant again, because we're looking at that triangle. Y, K, and X, all of these are Y equals. So all of them have an x, we're looking for what k is. So you're going to have to use your formula for constant. You're going to have to pick the easiest xy that you can find and do your division. That number, whatever this number is, has to go right here in this spot. It has to be being multiplied by x. If it's being added to x, it's not right. This is multiplication. I'm not going to help you with 8. It asks for the constant, so you need to set up your formula k equals y divided by x. If you need help with 9, it's exactly like number 7. Number 10 is exactly like number 1. Number 11, you're looking for the equation. You're looking for k. You're still looking for constant. So pick a nice, easy to read x and y, which is actually harder than it should be, right? I know. It looks to me like you have 4, 6 here. That would be the one I would use. Of course, you could try using a different one, but that's the one I would use. Whatever the answer to that is k in your answer choices. Be careful not to get the x and the y mixed up. Number 12, you're looking for the constant. You're looking for k. And I would probably use this dot here. 250 and 2. That's what I would use. But I think there might be, like, you might be able to use this dot up here